So, I hope this is running now. Hello, everyone, and welcome to this May tutorial. We will building something like this, like an abstract, squishy flower thing. You voted all on that on my Patreon page, and I'm really glad this was voted. Of course, there will be another one next month. Maybe a vote or maybe a collab. I don't know. Let's see how that will turn out. But I think I really like the result. And yeah, what I want to do is to give you basically like a quick overview on how I achieved this kind of geometry, then the simulation, etc. And then we will build it up from scratch. We will start not with the grass. We'll start with the main tree. And let's go out of here. And yeah, this is the tree. There are some of here that can be like deleted, of course, because um, this is like always like an R&D stage. And of course, this is not perfect, but I really like a few things that basically emerged from this kind of setup because I think there are a few really cool and interesting forms that you can create with this kind of quick or noise setup here and then later with the simulation, etc. But I will give you like a rundown now. And for example, this tree here, this was like a simulation that I tried, and it unfortunately it was way too like processing too slow. So then you come up, of course, in the process with other solutions, for example, like with point deform, um, and so on. And I think, yeah, it turned out pretty cool in the end. And I think we can start now. So first of all, I created this kind of shape here, which I think is pretty cool. Um, you basically skeletonized this. So you just keep like the lines and then play around with a little bit of thickness, merging different things together. This is a simple simulation here. Then there is this beautiful organized loop, um, which is basically a loop that will combine um, three like blooms together. And with those three blooms, they are like attached to the geometry. So this is like a 3D scan here. You can, of course, use any kind of geometry. I think a tree branch would also be really cool. Maybe I will use that. Um, and after that, we will poly reduce this, for example, one time for a collision geometry. And after the creation of our three, like basically simulation shapes, we'll conform that thing to a tetrahedral soft body. We will simulate that so it got like a little bit, wait, let me play that, like a little bit of wiggle, a little bit of stretching, a little bit of movement, which is, I think, pretty cool. After that, we will, yeah, I tried something with grains. We will point deform our original geometry to get the movement. Of course, you could simulate this in high res, but I think this is way too like time consuming. If you want to do like a close up, that could be possible. Then what I also did, created like a mask for the different shaders. So then we can, for example, in look development, we or you can can play around with the mask attribute and assign different materials or placing gradients, etc. Then there are always basically two groups. So one internal group and one external group, and the external group is basically this skeletonized cage for the flower, and then we have the internal shape. Then after this simulation tree, there is this little tree that creates those, I would say, cocoons. So they are like embedded. Let me just merge those two here. They're like basically, oh, that was not the right thing. Let's get back a few frames. They're basically like embedded in those stringy line things. And it's also like a loop. And after that, we will begin to simulate the whole thing. And it's a little bit wobbly, and then we will basically clean it out, we will smooth that, and we also got some nice organic movement going on here, which I really like. Dark for a second, which is also pretty cool, I think. After that, wait, let me stop that here for a second. Then we got like the cage, and we'll sweep that to give it a little bit of thickness. And this is like basically the whole setup. So that's it. And I think it's pretty cool. And of course we got the collider again here to collide with the whole things, and we've got a little bit of noise going on. So we have a time dependent noise that will blob out or like morph the flower a little bit. So the cool thing is, of course, you can do, for example, like this in the simulation. But for here, I think it's pretty nice to have that after the simulation, like a post non-sim effect, because you really can control it. And getting that in as a collider, which is pretty cool. So we got all collisions going on. So just get a sneak peek into here, how that will look. So we got then our collider, we got a glue constraint, we got a attach constraint to the original flower internal object. And after that, what I also did is to create it like a low poly version, and then scattered some points on it, and then some lines. And what I came up then is like a really simple, but I think really cool grass simulation. So let's hit the curve view. Let's just remap this to like a cooler color. So something like that. And then we will have this really organic grass simulation that's going on like in the background. Let me just template that. In the background for the whole other simulation. And I think it adds a nice bokeh and a nice environment effect in this case. Okay, let me just grab a wood geometry, I think from Quixel or on CG Trader, I don't know, to get another geometry to start with. So I will get again a whole new approach on this one. Of course, I will work with the same setup, but other geometry around of this, and then we can see if we scatter some grass on it or some other stuff later maybe. I think that would be pretty cool. And yeah, when I got the geometry imported, we can dive into this May Patreon thing, and I will hope you will enjoy it. So see you in a second. Hello everyone back. So I got this tree geometry here, and I think that looks pretty cool. And what I want to do, I want to place our little growing thingies, like maybe between here. So we got like, I don't know, maybe in between. Okay, I got like two cat blocks. I got like two ideas here. Maybe they could live like here, something like that. Or they could be around here, which I think is also pretty cool. But yeah, let's see. So I imported that. Let's rename that first. This will be our out main geo. Let's call it like that. Okay. So we will start this here. But now what we need to do first, let me just get on autosave here. What we need to do first, we need to build our basic geometry. And this we'll do with sphere and with a Voronoi fracture and a spiral, and yeah, we'll get something like this, which I think is a pretty cool to like play with geometries basically. So let's get a sphere here. And what I want to do is to get more of an elongated sphere. So I will get that to polygon and this to like 1. So I will stretch it out. And I think 15 is okay for the frequency. And what I want to do, Voronoi fracture. We'll place down a simple Voronoi fracture here. And what I did in this setup, I used like a spiral with a match size to like center the spiral and use that as a Voronoi fracture. And the cool thing is we can get like a lot of different setups with that. So let's get a match size and let's get a spiral. You can also use like the lap spiral. That's also pretty cool. But let's get to the spiral first. And what we need to do is to get increase per turns to 0 and the height. So I think I played like with the height a little bit here, like 4 or 2. So just like fully up to you. I will use maybe 3.5 here. And then you can play with the turns. Just get that in here. Let's get that centered. So center, center, center. Pipe that in here. And we will already have a pretty cool looking geometry here, which is, I think, a little bit too detailed. Of course, you can play with it, but I don't know. Let's go for maybe like 15. You can also play with the start radius. Of course, when you go to 0, you will get something like that. To 1, you will get something like that. I'm trying to get like a little bit of a different result. I think something like that can work pretty nicely. So we got like 3 ultimate divisions, so we don't got this like elongated setup. Because in this kind of setup we have like 2 long things, and now we got that a little bit more splitted, which I think is pretty cool. Okay, after the Voronoi fracture, we will then use a loop to isolate the lines basically, and then remesh it with a sweep and with some VDBs. Okay, let's get the loop running here. So what we will do, we'll place down for each connected piece, and this will run basically on each piece here. And what we need to do, we need to disable create interior surface. So this loop will then run over each piece here, which is pretty cool. So let's disable the single pass. And what I want to do is to create like a group for the unshared edges, and then the edge group to curve and smooth that a little bit out. Okay, so yeah, that's a perfect piece here. Let's get a little bit a bigger piece. So let's enable our single pass here. And what I want to do quickly is to make the loop white. Group. And let's call this grp edge split 01, for example. And I already got like the $OS function in here. So this will inherit the node name to the group. So we can see group edge split underscore 01 is now our group name. We will disable the base group and include by edges, unshared edges, and then switch the group type from primitive to edges. And then there is a cool node. It's called edge group to curve. So we will use that. There's also, I think, the polyline node. So this will create like a primitive for each line, but we will use the edge group to curve. Group edge split. And after that, we can use the labs at smooth and click include unshared edges. Pipe that to the loop in the end, and let's see. I used like basically, okay, no special thingies, but I resampled it. So what we then will do after the edge group, we'll place down like a resample and go on subdivision curves and get this like a good amount of resample. I think I did like 0.01 here. So 0.01, and now you can see we've got a smooth result. And after our loop, we will have something like this, which looks already pretty cool, in my opinion. Okay, nice. Then let's straight that loop out. You can straight like nodes out. So for example, if you got like several null nodes here, you can all select them all and then press A, and you will get your cursor will basically change to this kind of view, and then you can change them around in the horizontal or vertical layout, which is pretty cool and handy if you need to like organize your nodes a little bit. So this will be, let's just call this and call this out frame. Whoops, forgot the T. This will be out frame. After that, what I want to do is to like offset it like a little bit and then create a sweep. That's basically it. Okay, let's create like the normals here on the points. And I already got a preset for the displays along normal. It's basically add position plus equals and then open brackets at normal times a channel. And in this case, it's a multiply channel. You can also use the peak node. This is like basically the same thing. So you can use a peak node, or you could use an attribute WAP, go in there and use a displays along normal. This is also basically the same thing, and it displays it like that. So this is also possible, but I just used like a little wrangle here. So set displacement, and let's have a look at the value. I think it was pretty low, yeah, 0.0215. And here's the before and after, so it's just like a little displacement. After that, we want to sweep it and then getting the balloon in here. Okay, let's go for a sweep. Sweep node. Oh, that's beautiful. We need to attribute delete all the attributes before. So delete all. You will just type in star, 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 star. And when you did that, you can get like a save preset. And then, for example, delete all. And that's what I did here. Delete all attributes. And every time I will click that, I will get my stars in here. So I know we'll just got the position. And now we can place, for example, the sweep. And we will go down a little bit with the radius. I think I used like a similar radius, like here 0.01, like a little bit thicker. And yeah, already looks pretty nice. Then we can remesh it and smooth it. So let's get a VDB from polygons. Pipe that down here. 0.01. Let's go. 0.0025, I think that should be fine, and after that we can smooth it like a little bit, which I think is pretty cool. 8? I think 8 should be fine. I don't know the values from this one. Let's have a look. 4, okay. And then we can convert it, and we can use this converted frame or outer rim as a collider. And what I want to do is like maybe poly reduce it for that. I think that would be a cool idea. You can just play around with the adaptivity here. This does a really good and extremely fast job if you need to poly reduce like a VDB after the conversion, which is pretty cool. So we got our first little tree here, which is cool. Then we will got the out base, we'll subdivide it, and we will create a small little property, constraint property to then let that whole thing like grow and emerge a little bit. So what we will do, we'll get our sphere here and just call that, let's call it out internal. And we will subdivide it like a few times. And we will go to open subdiv loop and velum configure balloon. Let's place that down. And with the velum configure balloon, what I want to do, just leave that basically as it is. So I think that's already a good value. But what we need is to get like a stretch group, so we can work on the stretch constraints here. And let's call it stretch grp. Let's copy the name here. And what I want to do, I want to place down a velum solver. And let's move that down a little bit, get a null here, and let's call that in collider. And we will pipe that into the collision geometry here. So we will have our little collider here. And then we can blow up our balloon. Let me just see how, okay, 5 substeps. Then let's just use like 5 substeps and disable the forces here. And what I want to do is to work on the stretch group. So dive inside and let's get a velum constraint properties node. Pipe that into the force output, enable the group. And we will use the stretch underscore group and we'll use the rest length scale. And now what we can do, we can animate that. For example, from frame 1 to, I don't know, let's go on manual to frame 24. And I don't know what value I use, but let's use 5 for now, because we will save, we'll basically save a still frame out of this. And let's just have a look here. Maybe we also need to like increase a little bit the resolution of our balloon. But I think that already looks pretty promising and cool. What's also like a good method or like a good little reminder, try to get your pockets, so basically your frames here, pretty equal as possible. Of course you can pin them down if you want, so you can make a mask from this and then pin the points down, or like with a stitch point constraint, etc. But with this kind of setup, it could like slip out, like the whole balloon could slip out of like one big pocket. But of course we will not simulate that far. Let's just simulate like a little bit further. And I think that looks pretty cool. And we will use something like this state here, like frame 8. Come on, that's fine. Frame 15, okay. We of course we can go further, but I think that's what I also did on this kind of setup here. I think I used like not that of a high value. Yes, 4. I used 4 here. Okay, so this is pretty cool. Let's just use like vellum post process here. Get it in here, subdivide it one more time, and I think that looks pretty fine to me here. And after that, we can use a time shift. Time shift. And in this case, we will use, for example, frame 11, I think. Or let's just use frame 12. And what I want to do, I want to blur the whole thing, maybe like a little bit. And let's go for frame 9. I think that was fully fine. Okay, cool. Then what we can do, we can merge those two things together and assign our materials. Don't assign our materials. This was just like a test material to render. Assign our groups. So we'll now get into the grouping thing. So let's get 2 nulls here. And to like stay organized, of course. And this will be out internal flower. And this here will be our out, let's call it frame flower. Then we can merge them both together. And what we then also can do is set up groups. So group 1. And I don't know how I call that. Frame and group internal. Okay. Let's call that true group frame. Whoops, 001. And let's copy the node and we will call that also internal. Uh, 001. Cool. Let's just grab them both and get them to merge. And now you can already see we've got our main geometry to simulator. Cool. So let's go to like basically the next tree. What I want to do here, just to elaborate that thing again, is to create a simple copy to point setup to like copy those things together. And now of course it will try to sim. Let's just use a simmed frame here to like copy them. And we will use then the copy to point geometry to loop over them and create our simple reduced basically, or let's say it like that, we will create like a proxy geometry we can simulate, and later we can then point deform our geometry again. So let's do that. Let's go back to 50, no, 50? 15 here. Okay, we need a circle, scatter, and then a transform. This is important for later because we'll also use like array thing here to like array the geometry into place, or just to get a quick location or like an initial location. I want to go for like 7. I think that's cooler. Well, let's go 8. Because we of course need to place our geometry somehow in this whole thing here, which we will do. This is not a problem. Okay, maybe we will scale up the tree a little bit. Let's go for this thing. So we will create this setup now. Let's go for a circle. And of course you can scatter as many as you like. I will go again for 3 because it's nice to like simulate. And I think rule of odds, of course. I think it's a cool number. So we got a transform here, and what we need to do, we will basically get a little rotation function going on in here, and a little p-scale function going on here, to like basically just get a random scale for each geometry, and then also like a random rotation. Okay, let's do that. So we've got copy to points. So let's see how that will look. Looks already pretty good. What we need to do, let's go for an attribute wrangle, or you can just go for a random. You also can use, for example, the float attribute adjust float. This is also like a really cool node that can do this. So you just go like set initial, random, and then for example between 0.5 and 1, and then you can play with the seed here. So let's just use that. Of course you can use vex. So for example this is like a random p-scale function. Let's disable that. Let's get the thingies in here. This is basically the same. You need to type here. You need to not do a lot of things with the p-scale function, or with the attribute adjust float node, which is also pretty cool. So if nodes are available that will do stuff for you and do it right and do it like in a good processing way, so you can like have a lot of control with them, I think then it's like fully fine. Let's find like a cool seed here. So I want like maybe like a scaling, yeah, like 1, 2, 3, like one big one, one like medium one, and one small one. I think that can look pretty cool. And what I also want to do is like get a random rotation and a connectivity on those things. So let's place a point warp, or also an attribute warp will of course work. We'll just need to work on the points. Let's go for set rotation and dive in there. And what I want to do, I want to get a random node. I want to get a degree to radians node. I want to get a quaternion node, export node, find export. And that's basically it, I think. So what I want to do, I want to create a random value from our point number. Oh, we need a fit node. Then I want to fit that random point number, which is from the random node, is basically 0 to 1. So we will work in like a 0 to 1 range. And what I want to do is to remap that. So I want to remap this kind of value between minus 360 and positive 360. And this will be our degrees. And we will then convert those basically to radians. Oh, and we need an axis, of course. Get the rod attribute in here. and yeah, you can see those thingies are a little bit lost. So let's get a constant in here and a float and 1. And now the cool thing is we got random rotation on those. And what we also can do is to get an add here, for example, and a parameter as an integer, and we can then play around with different seed values. So I think that's also cool, but I will just use like the default seed and the default rotation. And you could, for example, animate those now, which I think is also pretty cool. Okay, let's go back to 360. And I think this is a cool, simple setup to like randomly rotate things, so you can see like before, after. Okay, now we need a connectivity. Connectivity. To get a connectivity attribute on our points, and this will then translate through our copy to points. And what I want to do, I want to delete all attributes here again, and then we will have a class attribute. Let's visualize that. Yes, on our copied geometry, so we can now go over this class attribute and go over each single one of that in a loop, of course. Okay, now let's go to our little next chapter, and our next little chapter will be to create our proxy geometry for each little flower here. So let's start on that. So welcome back. What we will do now, we will set up basically our proxy geos. So we got copy the points here, and what I want to do, I want to promote the class attribute so we can run through the loop, and also I want to include our tree geometry or whatever geometry you like. Maybe you did something self-made or imported a scan, etc., etc. We will connect a few lines to them so we can simulate like a first little wiggle thing with the tetrahedral soft body setup. So we will dive into that loop now, and what I want to do is to just get a null here. This will be out flowers copied. So those are our flowers, and now you can see we've got the class attribute, and we need to promote. So attribute promote our class attribute from point to primitive. And now we can also see we've got that on our primitives, and then we will place down for each connected piece, delete this one here, and just run that through. And now we will go through each flower. So let me demonstrate that quickly with the single pass. So 1, 2, 3, which is pretty cool. And now we can basically single work on those. So we will create a convex hull, and then we will create some simple match movement. So we need to blast away a little bit, and we will match it back. To get like a procedural blasting or grouping effect. Of course, we could do that also with a mask or with a DOP product, etc. But I think this is for a way that just need to work, one of the easiest ways. Let me just check the audio. Okay, perfect. And yeah, we can then blast that thing away, and we will then ray that to our geometry, in our case, the tree. Cool. So let's get a convex hull started here. So we will place down the convex hull. It's a nice node to just get a quick, basically proxy geometry. And what I want to do, I want to make it like a little bit bigger, so minus 0.01. So we have a little bit more to work with. And this geometry is nice to get like like a quick approximation of our hull or of our shape. But the problem is, in this case, it's pretty, the topology is pretty messy. So what we then just will do is to place down a VB from Polygon and convert it back and remesh it, because we want to use that, of course, for our simulation, for the we'll use that for our soft body simulation. And we just need to like get a nice topology. Especially the best thing would be a remeshed tri topology. So we will do that. So we can use that for our simulation. And so we have a nice topology to basically work with. And this is here a little bit low res in my opinion. So we will pipe that up. So the target size, let's go to 0.01 maybe, but I think that could be too high. So let's dial that up to 5 and the iterations to 10, and we can smooth it out like a little bit. I think that should be fine. And now let's get the viewing flag on here and the template flag on here. And you can see we've got our proxy geometry, and the cool thing is we also got a little bit of offset. So this will come handy, will come in handy later for example, simulation with collision. So we got that a little bit extra of a puffer geometry around our flowers. So now the procedural group, this is really easy. We will use like the match size, and we will not use like the scale. We will just stash the transform, and let's go set rest. I think set rest is a cool expression for that, or at least a good word. And we will need a group node, and what we will do, we will just blast like the bottom away. Keep in bounding regions, and we will go for bounding sphere. And let's just go for min. And I got the sphere here. Let's move that down a little bit. And now basically every proxy geometry will get moved in the y direction to 0. And we then can have our group procedurally select this area, and then we can delete it for stuff later. So let's just call it group blast connect, because we will connect our set rest back. We will connect our flowers with the tree geometry later. And then we'll just need to hit here, reset xform. And that's basically it. So now, when you let that run through all 3 of them, or 4, 10, 20, the cool thing is when we go to color, and let's color that in blue, and let's choose the group. We will have a group here that is evenly spaced or evenly big on our geometry. Now we got a match size. Now we need to like basically import our geometry here. And what I want to do is to maybe poly reduce it. I don't know yet, but let's have a look. And of course, what we also need to do, we need to place our geometry somehow in a cool way, but we will do that in a second. So what I want to do first is to just scale the thing here up like a little bit. I think that could work nicely. Let's go to scale 2, because why not? And I want to have them, I think between here would be cool, or also between here, but then we need to, let's make our direction choice here. Yes. I think between there would be. And then we can get a nice angle, for example, from here. Like, let me just isolate that. For example, like a vertical camera would be something, or like an Instagram format would be something like that. And more of a CinemaScope format, and our flowers will live in, oh my god. Our flowers will live in here. Perfect drawing. But then, for example, a CinemaScope format or a more eye-friendly format would be then, for example, something like this. And I think that's pretty nice because we've got a cool a ratio with the trunk or the tree here, and we got a little bit of negative space here, here, and here, and I think that will work nicely. Okay, so we did our artistic choice. Let's just move that thing here into the middle point. We don't need to arrange a lot. That should be fine. Let's go from top. 0 here should be fine. Yes. Okay, cool. Perfect. Then we got that. Then we need to like add and enumerate stuff and ray the points down. So we'll basically do that. Let's go here. Let's get the blast node. We'll blast stuff away. Let's go for deselect. And that should, yes, looking good. Then let's go for add. And we will just keep the points. And then we will use an enumerate. Points, and let's call that connect_ID. Because sometimes it will interference or not handle well with, for example, the ID on Vellum objects, or for example in a DOP simulation. So be aware of that when you do something like that, you can just rename that, or rename it after even, or delete one attribute. So what I did here, let's just show that quickly and disable the flag here. What I did here was just painting like a quick mask. So I want to connect the points here, and we'll do the same thing here. So let's see, we've got our 3 little thingies living here. I think that's a fairly good place. That's not bad. I think that could work out well. But what I want to do, I want to tilt them like a little bit. And I think like a little bit of a tilt is pretty cool here. And what I want to do, a little bit of rotation. So when we got our camera here, yes, that sounds good. Or that looks good. Okay, let's just run that through here quickly. And let's reset our little loop. Yep. That looks good. Then I want to array the points, and I need a delete node. And what else? A mask node. So paint a mask. You can of course also do that procedural. I will do it manually now because I think painting like a little bit is cool. What I want to do, I want to connect them to just like a little bit basically down here. So just make a blob of paint. Let's get here a little bit erasing. Let's erase that. And what I want to do, I want to delete by expression and then add mask equals 1. And that will just basically delete everything that will have a value of 1 at the mask attribute. And then just delete non-selected. So we basically invert the whole selection. Then we will array that down. So we will use that as a collision. And what I want to do, I want to entry points and then minimum distance, and it will array the stuff down. And because we enumerated them, so we gave them a unique attribute for each point number, we can merge the two streams together. And we can then by group attributes and connect underscore ID, and now we've got our connection point here. Of course, this would also work if you don't have the delete thing, because it will try to search for the closest distance. But yeah, just to be sure that there will be no errors. I think that's fully fine. So now we need to transfer an attribute. What I want to do, I want to transform an attribute, and let's just rename it. I did not rename that here. So whoops. What I want to do, I want to rename that probable. We need here the class attribute. So we basically got our unique class attribute back on our proxy geometry. That's pretty important because it will get lost in the remesh process. So let's get that back, and now we can rename that properly. This will be our out proxy. And with our out proxy, we then can also create a group to like basically split that, and we can also create like an attached group. I don't know if I did use that. I don't think so. Nope. That was another workflow. So we don't need that group, but we need a group to split the whole thing. So grp split. Oh, oops. We need a group first. Let's get a group. And with the group here, we can rename that to grp split. Oops, let's call that 01. And let's just merge them together. So the one thing will be our attachment strings, and the other thing will be our proxy to simulate our soft body. I think that looks already pretty good. So let's just get in here, place a null. this will be the out proxy. 1, nice. Out proxy. No, let's just call it out proxy flowers. I think that should be fine. Okay, let's save the file. And then what we can do, we will basically split the whole thing. So we can convert one to tetrahedral soft body, and then we will create a group for the pin and a group for the hair. And I forgot to resample that. That's not good. Let's have a look at the resolution here. Yeah, 0.25. So not a high resolution. So this is currently our points, and we just use 0.25 and a curve view attribute that will come in handy in a second, because we will use the curve view to find the endpoint. And then let's split the whole thing. And we will use the group split to split it. And this will be our out constraints. And what I want to do, I want to give them a group. So this will be our hair group basically. GRP hair 001. And then a group expression. And what I want to do, I want to get the point pin 001. Did I also named it like that? Yeah. I want the point with curve view of 0. So basically the points down here. And I also got, or I already got, of course, like a little preset for that, but let's just type that in. So we'll use add curve view equals 1. Oops. Curve view. Oh, 0, not 1. And we got our pin endpoints, so we can pin our vellum directly to that. And then we got proxy sim. And what I want to do, I want to get just a tetrahedral conform, tetrahedral setup vellum configure tetrahedral soft body. And we will use that, and the cool thing is we can basically merge them back together, so not with that, but that here, alt, that, and this will be our tetrahedral soft body. And this takes just like a few seconds. So this is now converted to a tetrahedral soft body. It's basically like filled with polygons. So when we slice that or clip that, you can see it's basically filled with polygons. And later some may get, or I got a few DMs because soft bodies don't like render as usual. The thing is, there's now another category, the tetrahedrons, and after the vellum sim you need to get the convert tats node to convert basically the whole thing back, but we will of course do that. Okay, now we got our tetrahedral. I changed like a little bit down the stretch stiffness. And after that, we will need 2 more nodes. This is one hair and one glue. So what I want to do is vellum hair. And we will use that on our hair group. So group hair. Visualize thickness. And we will need to go thinner on those. Something like that. should be fine. And what I also want to do, what I also did here, of course, I want to pin them. So let's get our group. And this should be like permanent, and yeah, that's basically it. And then I want to get a little bit of glue in here. Let's just wait for that so I can show you how that will basically work. Or I will just show you it here. What I want to do is to basically like glue the underside on our geometry. So vellum constraint. Get that, and we want to get the glue constraint. And I want to work basically again back on the hair, and let's just disable the visualize thickness. And what I want to do is to get our primitives involved here. I want to basically just glue them onto here. Wait, just do it like that. Only the constraints. And you can see the glue constraint will scale up to that. And let's just use a few more, like, I don't know, maybe like 15. And the search preference is the nearest. And you can also like set in a given search distance, for example. And then what we then can do, we'll raise the stiffness like a little bit up. And after that, we will place down a vellum solver. And then we can simulate. We will disable gravity. Of course, you, for example, you can enable it and see how it will look. And I think that should be everything. Yes, we need to get the collision in here. Soft body. This will be our collider. We can also reduce the collider, of course. But this is now basically our simulation. But we will also, we will only use it without gravity, and then we will get like a little attract force in the center and a little bit of wind going on, etc. So what I want to do, I want to pipe up the subsets to 3, and I think constraints I did 150 or 200. And what I want to do, I want to get a pop attract into center here. So just to get like a little bit of attraction. So not much. I think I used like a really low value in my setup, but for this setup now we can of course get a little bit higher. Oh, okay. I used the standard value. Never mind. Let's go back in here. And then a pop wind. And I used 2 pop winds, one with a larger amplitude and with a larger swirl scale basically, and the other one with like a little bit lower frequency swirl size, and a little bit lower amplitude, I think. So swirl size, this are our units. Let's use like 1.5, an amplitude of 1.5. And then we'll use like a second one to introduce like a little bit more motion in like a high frequency. So 0.25. Well, let's just go for 0.5. And disable gravity. Okay. And after that, we can place down a file cache. And let's rename that probably. Let's rename that to cache softbody 001. And then I will cache that, and I will see you in a few seconds. Just cached out, or I simmed our little thing here. And I think it works pretty well. So we got like the collision And then we've got a little bit wiggly going on. And I think that looks pretty nice. So now we cache them out. So we can place another null here. This will be out cache. Let's just rename it like that. And after that, what I want to do, I want to grab my initial geometry from above here. Let's place a null here, out, let's just call it out geo, I don't know, I think that should be fine. And with the out geo, we then can split them, mask them together, and create later a little animation on our flowers. So I think that is pretty cool to do. And what we also need to do is to basically point deform the whole thing. So we get like the high res geo on the low res proxies and get the movement. So things that we need to do. Let's just first split it. Let's call that our geo mask. I think that will be a little bit better. And what I want to do is just get a split here. And I really like that, as you just can like split stuff and merge it back together, and you can make a workflow, for example, in between those two nodes. And what I want to do, I want to split the frame and the internal. So we got the frame and the internal stuff. And let's get a mask from geometry. And we need to invert that thing. And what I just want to do is to make a small little mask, blur that and merge them back together. So we got this output and this output. So they're both back together here. And now we can press on visualize, enable the visualizer, and then get here a little bit less. I think something like that should work nicely. And an attribute blur. And we want to blur not precision, we want to blur the mask here. And I would go for like 15 iterations. Of course, you can play around with that because that will basically directly influence the shader. So you can also go a little bit higher. So for example, 35. That gives you like a smoother transition, which is also pretty cool, I think. Okay, then we've got this little part. And now we need to, again, make basically two parts. So we've got a time shifted rest geo here. We got our high res geo, and we've got our moving geometry. So we'll just do that. So split. And then what I want to do, I want to basically split again with the group split, or for example, you can also, in that case, what will be more elegant would be like a mask and then split. So we can split away the hair things. And then what we can do, we can get a time shift and convert it back. So let's get a time shift. Oops, not time blend. Time shift, shift enter. And I want the first frame. So this will be our rest geometry, and let's just get a rest attribute on there. And what I want to do, the one little important step, is convert it to tetrahedron, convert it back to polygons basically. So convert tats. And we got, when we, for example, clip now the geometry, it's just basically a normal geometry and not filled inside with those little tetrahedral polys. Okay. Now we've got like our rest attribute, we converted that, and now we need point deform. So point deform. We need our high res geometry, into the left input, then our rest point lattice to our middle input, and then we need it. Oh, well, I think I deleted it. Convert tets. And then we need that again for our moving geometry. And pipe that in here. And you will see something like that. You can use the piece attribute and, for example, go a little bit wider with the radius. But I think something like that should work really nice. Let's change the frame number and we see that works quite well. Nice. So we got our geometry that's a little bit deforming, a little bit wiggly, etc. So we've got a point deform. And after that, we want to place down our little controller here for the noise on top. Because what I want to do, of course, you can use the mask as a shader, basically, to then play with Octane or Redshift, etc. in the shaders. But of course, you can also use it for VOP operations, or basically typology operations. So for example, we will not change something, we will not like delete something. You can do that too, by the way, which what I really like. The cool thing is what you could do. Just a quick insight, you can, as an idea, mask equals 1, you could basically delete everything else and let's just get 2 here. And I think that could look also really cool. Because you then could like place a geometry inside of it. With the mask here, you can go for like an invert and give it more contrast. And what you then could do, you could delete the whole thing and then smooth the edges out again, include unshared edge. So I think this is also like a cool way. Let's just get a null here to like do something like that. So this could also be a thing, but of course that's fully up to you. Cool. Then we will dive inside our little VOP here, and let's call this set deform post, and let's dive inside. Deform, dive inside. I want an anti-aliased noise, and first of all I want to see the scale of it. So this too large, so let's pipe up the frequency a little bit. I will go way down on the roughness, and what I want to do after that is to displace our things along the normals. And then I want to add the noise here. Oh yeah, that's beautiful. You could remesh it, that could look cool. Then I want to bind our mask. So the mask that we created on top of here, we will now bind that in. So basically we will import it. Mask, scale. And then a ramp. So we can control that whole thing. And then I want a multiply. And I want a parameter. And this will be our multiply parameter. So we control it from top. So let's just call that mult for multiply. After that, we will place down a vector to vector 4. So we'll use our point, pipe that in here, and we will use a 4th value basically to drive the whole thing with a multiply constant, and we can set that, for example, to 0.1. think that should be fine. And that's basically it. So right now we need to, let's check the frequency again. Let's just play with the a little bit. And with the amplitude, I think an amplitude of 2 should work well. And let's just for a moment time shift that. So just basically freeze it. So our point deform does not need to calculate from the top. And let's go for 0.025. Now we have a nice moving geometry here. Of course, we can isolate that a little bit. And we will just work on the internal things. And I think that looks pretty fine to me. Nice. So we've got our deformation from post. And that's basically it. So this is our first final output. Let's just place a null here and call that outflower final. And what I want to do, I want to split it and merge it again for the shaders. So split it. Whoops. Let's get a material here. OC matte. I will render with Octane this time. Of course, you can do it with Redshift, Mantra, etc. Let's call that internal. Is a mantra? I think I wanted to say comma. And frame. And then merge that basically back together. And we can play that. We can place this after that. That looks good. Nice. So this is our basically our first output from the whole tree here, getting pretty large. Okay, cool. After that, we got our geometry. So let's just pipe that directly into material here. And what I want to do, let's call it OC matte tree. And I think it looks cool, but I think it's not high res enough. So I will just go VDB from polygons. And what I want to do then after that is again a VDB convert. And I just want to get the UVs back. So let's get 0.01. I think that should make a nice high geometry. Yes, that should work good. And then after that, we can, for example, poly reduce it a little bit. And of course, you can only choose like the output of it. So when we only take this in frame, which looks pretty cool, we can then, for example, cut down here and cut down here to like reduce the poly size. But what I want to do is I want to get a poly reduce because I think a poly reduce will do a pretty good job. Yes, it's a little bit time consuming, but I think that's fully fine. So let's just analyze the geometry here. And after that, we can keep continuing. Okay, let's just go for 25%. I think that should be fine. And yes, that takes a while. Let's just cancel that. And for a quick, I think for like tutorial wise, it's fine. But if you then later render that, please use like a high res geo. Okay, yeah, that's way better. Let's just use that for now. Should be fine with the poly count. Let's have a look. Yes, that's fine. We can also increase it like a little bit. Yes, and attribute transfer. You can, for example, use the UV transfer from labs. It's the labs UV transfer node. This one is pretty good. The target geometry, and then go way up here. I think it's a little bit slower than a normal attribute transfer. But for example, for like intricate details, etc., I think the UV transfer from labs is sometimes a little bit better. For example, on this one, it will now go through a cell for each loops to like calculate the right position, etc., which is pretty cool, I think. But of course, it takes a little bit of time. And you can also just use for something like that. It's, I think, fully fine to use a normal attribute transfer and use that. And then vertex, vertices, and just transfer the whole stuff over it. And I think that's fully fine for now. Cool. So let's just delete that. We can do, so this is like a little bit more streamlined. Get a null in here. And then we can place it basically around here, so it looks a little bit cooler. Let's improve our aesthetics on the node network. Oh yeah, nice job. Okay, this will be our render geometry. So we will render that out. Let's just not rename this, so, because it will then need to cook again. Okay, so this is our tree. Let's just also give that a name, out tree. Final. Let's go for final. And then we need to build two more little things. First of all, our little cages. And let's just do that. I will give you like a quick rundown. So what we will do, we will use our proxy geometry, extract basically like the centroid of it and copy like a line to it. And for like transformed little thingies, we can just like eyeball it for now. Then ray it basically. Oh wait, let me just fully reduce that. But I think that one is pretty okay speed wise. So that's okay. We'll basically array like the endpoints to it, resample it, sweep it, and then get a mask and basically displace it and smooth it out. So I think that's a pretty cool workflow to not like simulate everything. I think that's pretty strong, especially when you need to work, for example, for a client. And sometimes on a client project, you need to do a lot of iterations, for example. And I think sometimes a more non-simulated workflow that you then can simulate, for example, like here after the fact, I think it's sometimes a little bit better. But of course, That depends on the project, that depends on deadlines, and so on and so on. So let's just start with the whole tree here. We will start from here. So let's get a null here. Let's go out. Let's call that, I don't know, out for cage. I think that's a good name. And what we can do, in fact, let's go back to frame 0, and we got, let's get a time shift. Let's also do it on this side. Time shift. We can do that. Let's use this one. Okay, that's looking good. And what we did here, we basically transformed our thingies here a little bit. So what we could do, we can just copy the transform here and keep that in for later. What I want to do then is to go over each again and extract stuff. And so, hello, welcome back. I found a solution to our little cages here, and let's just rebuild that one, because those are of course tilted, and in this example they are like 90-degree straight. And what I want to do, let's get first again, I want not the proxies, I want a time frame from the proxies. So time shift, and just get the first frame here. And let's see if it's recording. Yes, okay. And then we need for later, where is it? We need our tree here. So this will be a null, and let's just call that out tree for the ray. So this will be the geometry to then ray onto like the points for later. Okay, we've got that and we've got that. Let's go for each of those. And we will build it up. Okay, we are time dependent. Again, we should not be time dependent. Let's just save the file quickly. Another time shift thing here. Okay, now we are not time dependent. Nice. Okay, cool. So what I want to do is to get, I did it here with a copy to points and lines. We cannot do that here because we need the angle of those geometries. So what I want to do is just get a rig, a skeleton, a lab straight skeleton, and we can build it like that. And this is pretty cool. So we will just get a skeleton out of this one. So of course this will be like a basic line. And what we then can do, we can basically resample and attribute delete everything, because we don't need the stuff on here. And what I want to do, those are currently a few points. I want to resample it. And after that, I want to smooth it. So smooth out. To get it like pretty straight. Let's go to 50. And what I want to do, I want to scale it up a little bit, but from the center. So I will use the centroid function. This is just like centroid, open bracket 0, 0, and then 0, 1 and 0, 2. And I want to just scale it like a little bit, for example, like that. Okay, let's template that further. What I want to do then, I want to get a group expression, and I want the endpoints. So GRP and PTS, and this will be again the add curve view function. So add curve view equals 1 and add curve view or it's an OR gate, I think. Add curve view equals 0. And now we've got basically both points here marked for our ray. So let's get the ray here. Collection primitives, let's switch that. And what I want to do is to get the minimum distance. And I want to ray the last 2 points. So group NPTS. And we will get something like this here. After that, what I also want to do is to resample it, smooth it, sweep it, and then some couple of steps after that to deal with the size difference of each little flower. So what I want to do now, let's just organize that here, is to resample it again. So let's get a resample node here. And I want to do that on subdivision curves, should just like smooth it a little bit out. Of course, we'll later sim that, but I think that's a nice way to do it. And then a sweep and another sweep for the normals. So this will be around tube, and we will give that some segments here. Nice. And then here again around tube, but we will use the columns. And let's just scale that a little bit down. And then I want to attribute transfer our normals from the first sweep. Let's assign point normals to those. Of course, we don't need to do that, but just for the thing. We got now point normals, and we need a mask from geometry. Let's get the mask from geometry on top here. Let's scale it down a little bit. And now we can basically displace it. So let's get a VLOP, point WOP, call this set displace sweep, for example. And dive inside. After we dove inside, we can place down displace alone normal, and we will basically displace now the sweep with the mask on top. So we will import our mask here. Wow, that's a lot. And we don't need that huge amount of displacement. So just for example like this. And what I also want to do, I want to give it one full twist. And after that, we can smooth it for the first time. So it looks a little bit better, and we can go down a little bit with that thing. Yeah, something like that. Should work fine, and we can give it a little bit more resolution. Yeah, I think that's better. Okay, cool. After that, what I want to do, I want to basically ray those again on our collision geometry and then displace it again. So we just got like a really nice, accurate presentation or representation of our lines on the geometry. So what I want to do, let's get a group expression. And let's call that GRP ray back, for example. I want points and then add mask larger than, I don't know, 0.2. Oh, let's switch that. Something like that should work fine. And again, another array node. Switch that, whoops, switch it. Minimum and just the array back group. And now what we can do, we can just copy, paste it here. And now we can displace it a little bit less. So we got basically two displacements going on here. One with a higher value, the second one at a second stage with a lower value. And then we can smooth the whole thing out again, and we will end up with a really nice geometry. And now we can run that through our sweet little loop here. And that should work as intended. It takes a little bit to like calculate the skeleton, but that works fine, and we have no collision at all, and everybody is happy. That's cool. Of course, you can, for example, fix something like that in a process. That would be like, wait, let's just get this one here to 1. That should take care of those little big swirls, but this is due to the range of the, maybe the point mask. But let's just smooth that out a little bit more. Yeah, that's way better. Cool. We've got those, and we've got our tree. So they are now attached to our tree here, and we can finally place another null for the simulation. So this will be null out cage. Cool. Let's get that a little bit better organized. So this will be somewhere around here. This will be down here because this is finished. This null will also be down here because it's also finished. And now let's check the record. Okay, and now we need to basically simulate that. So what I want to do, let's just go to the other side quickly. What I want to do is create a hair simulation and glue them together to get a little bit of, yeah, a stable sim, and attach them back to our collision geometry and then sim it. So this will take now a little bit of time to calculate, but I will just show you that here. Okay, first of all, we need to resample that and create another hair group, like another group pin, because I want to pin them down here and here. So basically on the start and on the end. So we'll go, let's just resample them again. And I want to have a quick look about the resolution here. Okay, 0. Yeah, it's fully fine. Nice. And of course, curve view. And what we can use, we can just copy it here. And now it needs to cook again. Oh no, that was my fault. Let's just cook that again. And I got already the scissors here to like cut it. Cut the node with lightning speed here. Group endpoints for, let's just call it cage and PTS. And what we also can do, we can attribute delete basically anything from here because we don't need those attributes. Okay, we've got now our start and endpoints, and now we can build up the sim. So we need the collision. Let's get the collision from here. In collider, and vellum here. This will be our vellum here, and I want to pin them down to, whoops, cage. Cage PTS. And what I want to do, I want to then make a glue constraint, and then an attach to geometry. The glue will basically glue the whole thing together a little bit. Constraint geometry, so vellum constraints, and we will use the glue for now. Yes, and way more constraints. And I also want to pump up the search distance, so you can see we will get a really nice type of constraint here. Let's just not get too long. I think that should be fully fine for like an early stage. And for the glue, I want to like increase the damping ratio. And after that, we will place another vellum constraint, vellum constraints, and an attached to geometry. And let's not forget to get our collider in here. And here we need a max distance, so it will not attach basically to anything. And another thing what we of course can do here to be a little bit cheaper with our calculation time, we can basically use here our little proxy geometry to attach that. And then a vellum solver. And the good thing is we've got here our moving collision. And now don't simulate it, please. Not yet. Okay. Reset simulation. Oh, this will cook the skeleton again. Perfect. Let's just freeze one node in there quickly after the simulation is done, or the cooking is done. Let's just freeze that. What I want to do on like the vellum solver, I want to drag and velocity damp and then pipe up the substeps and the constraints iterations, and for the initial simulation just add like a little bit of wind in there, which I think is pretty cool. Of course we will get movement because we attached those strings to our collision geometry, but I think it's a nice step to introduce, for example, like a second force. So this allo gravity, and then velocity dumping and wind drag maybe to 0.5. I think that should be fine. Let's just have a look here again. 1 and 0.5. Yeah, okay, let's just go for 1. And then go inside, and we will place down a pop wind with a little bit of force. And I think like the swirl size, we can get that a little bit down to like half, so 0.5. I think that should be fine. And then basically what I will do now, I will get myself a T, I will sim that and see you in a few seconds. So I will see you in the next little part. Hello again and welcome to the next little part. The sim is done and it's working really well. The thing what we now need to do is to basically smooth it out. Smooth it out. Nice. And after that, what I want to do is to place a sweep and an attribute delete. And I want to delete everything because we don't need all those attributes. Round tube. Of course, make them a lot smaller. And maybe like 16. And what I also want to do, I want to resample those a little bit. Maximum segments, and let's go for maybe 128. I think that should be a, yes, that should be a good resolution to work, or maybe double it. And then again, another post smooth on here to like smooth that out a little bit and getting a really good curvature flow. And I think that looks pretty cool to me. What you could do or can do, you can apply like a little bit of a scale along the curve. I think that also fits it really nicely. So you start like a little bit thicker and then getting a little bit thinner in both ends. I think that's also pretty cool. So this will be our third out. This will be out cage lines. Okay, now we got 3 outs. Let's just merge them. Because those are basically our 3 main outs. So we got like the overall structure. I love how that tree looks, by the way. I don't know why, but I like that it's like elongated and yeah, like pretty long, and I really like it. Okay, let's go. We need to do the grass. Yes, the grass. The question is where we will place it. Okay, let's do that. Let's have a look here. Okay, we need to place some grass. Okay, let's do that. What we can do, place down a null first, so out for mask, let's just call it like that, out for mask, and after that I want to paint a mask. I think that should be fully fine. And what I want to do, I already got Octane set up here, of course. Of course. And let's just get the camera started. Just get rid of those. And what I want to do is to get like a camera. Camera Octane R&D 001. I want to dive in here, and what I want to do, wait, let's just copy this camera. What I want to do is to change the resolution and 20 to 1080, and I think that also is a good aspect ratio for now. Sampling, that's fine. And let's just go for a second to the merge and display all outs. And what I think we can go a little bit wider here. So let's go 45 millimeters on the focal length. I think that could work quite well with this kind of perspective. Okay, let's dive back inside. And what I want to do is to basically paint where we want grass. So for like the camera angle, let's just go and paint here a little bit. Of course, you also can do it procedural, and we will do that. But I want to have a little bit of an overall control where I want my grass or my lines to appear. Just here and here. Let's just also go on the little one here. And like, let's make one big blob here. Blob. And I think down here is also pretty cool. Let's make that a little bit bigger. Down here, and maybe a little bit more to the side, and maybe let's just blob that full here. And in between here, I think is also pretty cool. Let's make a big blob in here. Nice. So we got now, whoops, our mask here. And what we will do, we will basically scatter points on a mask, play a little bit with a for each loop, get that down to a reasonable simulated point count, and then simulate the whole thing. So I want to place down a scatter node, and when you place the scatter node down, we will not scatter on the whole geometry, we will scatter on an attribute, and this attribute is called mask. And let's go for 45,000. I think that's, let's go higher. I think that's a good amount. Of course, we will delete some of them. That also looks pretty cool. The perspective, that's cool. After that, what I want to do is to get down a point warp. And I want to get an attribute adjust float for p-scale. And I want to place before the scatter down a normal. So we will have basically an up vector for our copies. Copy the points, and we want to copy lines. And we want to resample that. I don't know, just a few times here. And after the copy, we need to adjust the p-scale. So adjust value, set initial, random, and I want from minus, I don't know, 0.5 to maybe 1. I think that's like should be a good amount, and we need to place that into the z axis. Wrong camera. I think that works nicely, but let's dial that a little bit down. Maybe something like that. And what I want to do in here is to attribute delete the whole points by a loop with a noise basically. So pipe in a noise here. Let's just have a look. Frequency. I think we can go like a little bit bigger, so like 0.6. And what I want to do is dial up the amplitude a little bit and then a fit range, because the anti-alias noise is default for minus 0.5 to 0.5, and I just want to remap that. And then I want to compare it. So for example, less than, and then remove point. And this will be the handle. We need a ptnum, and we need to run that in a for loop. Oops. And let's connect that here. And now you can see we can basically remove that. And I think I did one more thing in here. Oh yes, it was the p-scale. Right, I do remember. Okay, with that we can basically, yeah, erase the points. Of course we got way less here then. So let's just go a little bit further. And don't delete maybe too many. And we can also play around with the noise a little bit. And with the offset. I think that should work fine. So it's a little bit like a little bit more broken up, a little bit more natural in the feeling on how it placed. And then what we can do, we will basically use another anti-aliased noise. And I want to bind, so again, import p-scale. And I want to multiply that with the noise. So we have a little bit more control over our scale. And yes, it's random from a certain value to a certain value, but now it's random with a given influence and a given like up and down from our noise. So bind export. Oops, it's saved. Yes. Bind export p-scale. And here we can again play with the values a little bit and play of course with the noise here and a little bit with the amplitude. And I think something like that should work fine. Then we can color this one in white. Everything is white. Well, let's just use a red so we know this is a loop. Cool. After that, we are ready to simulate. No, we are not ready to simulate. We need to do one more stuff again. Let's get a group expression, and what I want to do, I want to basically group again the endpoints. So GRP, not group expression, group and PTS. Let's call this grass. And again, the curfew function. And of course you need to enable curfew with 0. Cool. Now we got every point basically pinned. And now we need the hair and the vellum solver. So again, vellum configure hair. And we need to pin those. Now all points are pinned. And vellum solver. And on this one, on my last iteration, I played with the wind. But I think for now, what I want to do, it's trying to like simulate. That's not bad, but I don't need it currently. For now, when we play the simulation, the gravity will take over, and I think that's a cool thing. But what I want to do, I want to get like a more of not an upwind. I did that in the last simulation. More like a zero gravity effect would be cool, and like a little bit of swirl, maybe like in one direction. So adding like a little bit of wind. So what I want to do is get down a pop wind and a pop drag. Should just get a little bit of drag in here, 0.05. And a pop wind. And let's see. This is pretty big. So the swirl size should be like maybe 0.25. And let's go for an amplitude with 0.5. And then I want a wind direction. And I want it basically up slowly, and also like in minus z would be cool. So minus 0. Maybe 2. Oops. Okay, cool. Now we can again get a cache, file cache, grassim, let's call it grassim, hello 001. And we can basically place on our final null here out grass, and we will then import that in another geometry container. Cool. So I will simulate that and see you in a few seconds. To the next part. What I want to do here now is I cached it out and I did a few more things to it. So I actually changed the swirl size like a little bit. I made it a little bit higher. So it's now like 1.5 to get like a little bit more nicer overall movement. And that's basically it. So now we can get all of this juiciness, 3D juiciness together and render it. What we need to do, we need to export our geograss. I did that already here, but let's do it again. And then I got like a standard Octane setup. Cool. Get the material started again from scratch, of course, but those are like not that hard to do. Okay, geograss, dive inside. And then we need an object merge here. And what I want to import is the out grass one into this object, and then get an object parameter started. Those here, parameter, Octane, and let's go to fur, render as fur. And what I want to do, I will use another one here. Let's just copy that. And what I want to do quickly is to check the hair thickness. So let's just do that. Let's start Octane here for a second. Okay, that looks not bad, but let's first of all focus on our actual geometry. So let's start the rendering again. And this will need a little bit of time to like load the geometry in, but it's looking already nice, cool. I want to just get the focus here right. So the focus is now on our little abstract flowers. And you can see I really can boost like the thickness of the grass. So for example, like 5 and then maybe 2.5 on the tip thickness. And the cool thing, of course, what you also can do, you can increase the density. I think this is another thing you can do, like double the amount, for example. I think that will look much nicer. Let's just refresh the thing. Yeah. And I think that will look way better. Okay, now we need a few things. First of all, we need a backdrop. So let's get a geometry here. GeoBG. This will be our backdrop. Dive inside, let's get a grid. And what I want to do with this grid is to just place it behind our overall main geo. So let's just do that. Something like that. That all the way back. And make it way bigger, of course. Go back into the camera. Let's make it bigger. Size. Bigger. And what I want to do, I want to like bend it slightly. So not like much, but just like a little bit. So from here to here, just capture the geo. And just control the up vector a little bit to get things going. Yeah, perfect. And then just subdivide it like, I don't know, 2 or 3 times. That's not a lot of geometry, so that's fully fine. Maybe one more time. Okay, and then we will need a material here, and this will be OC matte BG for background, or you can also call it BD for backdrop. And then we will make a material. So Octane Material Builder. Let's place that down, and OC matte BG for our background. So this will be our first material. Let's connect a standard material to it, and let's go base color, specular roughness. Let's pipe that up. And what I also want to do, I want to change that back to, this is render target number 2. Nice. Okay, cool. Let's go in here. And let's just hit the 3. And the 3, let's get the material on this. Also matte 3. Let's copy the name. Go back in our shader, paste it in here. And what I want to do is just go back quickly. Of course, you can set like shortcuts with Control 1 and Control 2, for example. And then with 1 and 2, you can switch between those shortcuts. The tree, let's get the tree here. Nice, tree material, check. Let's just quickly start our render. And, whoa, we need to apply the background material. To apply the background material, BG. Pipe that also in here, just update that. And we can really bump up the thickness on our grass here. So not maybe too high, but yeah, just like a little bit. And of course the length. I think I would go for double the length in this kind of case to, yeah, just make it way more like fluffy. I think that would be a cool term to describe it. And now we got this. Then we need a third material. This will be our grass. And let's just apply our grass material. Render will be on the top level, grass. Cool. And then we need 2 more. 1, 2. We will need 1 flower internal and 1 flower frame. Oh, and I got currently an HDR to like light the whole thing here. So of course you can use your own light setup, which I will also use, of course, but for this quick demonstration, I think an HDR is fully fine. Just get a little bit more contrast in here. I think this is pretty cool with the darker background, but let's make it a little bit brighter. Okay, cool. Now for the tree, I got the texture lying around somewhere. Albedo. I will just use that for now, and I want to use a gradient because I want to control like a little bit the color of it. Yeah, that's beautiful. I kind of like that. Okay, let's go for like, I don't know. Maybe we could go for more realistic shading here, but let's just try things out. So for like a brownish to a yellowish color, let's desaturate that extremely and go a little bit on the value down. I think that looks not that bad. I think something like this is sweeter. Then the grass. For the grass, we need to go to Octane, attributes, point float attributes, and we need to pick out here our curfew. Where's the curfew? Let's just type that in. Curfew. So we will then have the curfew attribute. The question is it on there? Should be. No, it's not. Okay, let's just enable that. And now for the grass, we can go for a float vertex attribute, curfew, and then we can grade it. So gradient base color. Let's just refresh the scene here. We could also do like a full reload, but I think that should be fine. Yes, perfect. We can use the color from the tree to like adapt it a little bit. I think that would be cool, and it will like adapt the color of the greenish, of the brownish, and then rise like to this like green level, for example. I think that looks pretty okay. That's the wrong color. Shit. And don't go like too harsh on the transition. Okay, cool. For the background, also go for, well, like a wider color. We could also change the lighting here. Let's just keep it like that. Okay, so we got a tree, we got a background, we got our grass, and then we need the main geometry, of course. So let's just hook that up here. This will be internal, and this will be frame. Flower frame. Should be right. Ah, shit. I choose the R&D material from the first iteration. The flower should be right. Okay. Yes, perfect. Okay, then let's just quickly disable that. Jump in our main geometry container and merge them all together. So we can jump up again, start again our journey here. This will take a while. Oh, no, it's there. Okay. Cool. And now we can play, for example, for internal, I used like a little bit of, oh, we need one more material, right. I played with subsurface scattering. And then for the frame, I think I played with a little bit of like metal to dial in the metal in here. I forgot to set the split group. That's not good. That's better. And now it should also render. Let's give that a second. Yes, that's way better. Okay. Let's go back to the internal material here. And yes, I played like a little bit with subsurface scattering. So you can do that too. Or what I think is also really nice to play with glass. So it's a specular shader, for example. I think that's also pretty cool to get like really abstract. And then, for example, thin wall. I think that could also be kind of cool. But for now, let's just use that and go for a substance color. Like, I don't know, go for. Let's desaturate that. Okay, cool. And then we need one more material that I totally forgot. The cage. We need the cage output. So this will be cage. Oops. Cage. And this will be cage. Let's just jump in here, and it's not there, of course. So we'll just use the frame. Copy the name. Cage. There should be also material applied. And we need a sweep for that. Oh wait, never mind, it's here. We need to assign it. Basically bamboozled myself. Okay, now we got that. And let's again start the Octane IPR again. And it's gone again. And there it is. I think glass could work here really well, or like a more like a natural material. I think white is also cool. Let's try metal. This will of course be like really unrealistic, but why? Why go for realism? We already have that. And yes, the cage thing. Let's just dial it down. We could do like a specula on this one, but like glass holding the thing. And then we could go for a more subsurface material here. Maybe like an orange look. Maybe that could be cool. Or like a specular one here with orange. That could work. That looks like honey now. Maybe like a really desaturated setup. But I think like an opaque material, well, looks cooler here in that kind of setting. So let's go for the standard material again. And what I want to do is to get one more look. Let's just get that to the side. Dive into the camera. And I think, yeah, I did not like the perspective. I think something like that is cooler. And of course now you need like a lot more samples to clean that up. Or maybe like a wide shot could be also cool. That's also nice, but or like a really close-up one. I think a close-up one will also do like the job. Yeah, that looks also cool. But yeah, now you can decide on, of course, your own look depth, your own workflow, etc., on how you will sand, shade the whole thing. I think a few ideas are cool, so you can settle down on the look. Of course, I will do that also. I will now get my hands on there, I don't know, tomorrow or in the next days, and try some more shading out in a free time. In a free time slot. And yeah, I think that's it for this kind of tutorial. I hope you enjoyed it. And it would be cool if you will send me some of your creation on, I don't know, Instagram, over my email address, etc. So I can have a look at them, and yeah, then I can like repost it or reshare it, etc. for the future. Okay, I hope you like that and have a great day, and I will see you in the next one.